Hey everyone, welcome back to another fun and exciting Algebra 2 class. Today we are going to be jumping into lesson 7.3. We're going to be talking about logarithms. Logarithms are basically another type of function. We've talked about algebraic functions. We talked about the other type, which is transcendental functions. And inside of transcendental functions, you have exponential functions, which was last lesson. And now you have this thing called logarithmic functions. If you look down here at the screen, in your book, we're on page 340, page 340. If you look down here at the screen, it says the inverse of an exponential function is called a logarithmic function. So what does that mean? The inverse. Remember when we did the inverses back in lesson 7.1, where we switched the x and the y? Okay. Basically, that's what's happening right here is we're switching the x and the y from an exponential function, and then we're solving for y. So that's what we're doing. It's really the same process, really the same thing. If you followed that lesson 1, and if you followed lesson 2, then you're really ready for lesson 3 because it's just combining the two together, taking an exponential equation from lesson 2 and inverting it, which is what we did in lesson 1. All right, so let's look at what's called the standard form of the logarithmic function. This is the standard form, and this is on page 340. You have y equals log b. Now, that is interesting right there. We haven't seen that word log before. That means logarithmic. It's like a little shortcut of saying it. You don't have to say logarithmic every time. You just say log. In other words, every logarithmic function needs to be labeled. You need to tell everybody that you're working in a logarithmic function, because if you don't, they won't really know what to do. In other words, you have to have something that this base. Notice that it's what's called subscript. Okay? Superscript is like when you have an x to the b. Okay? Or an x to the 3. That's superscript. Well, now what we're dealing with here is we're dealing with subscript. The way I look at this is almost like, okay, so if my exponential equation was something like, I had my base to the x. When we invert it, it's almost like this, like flips. These two things flip spots, but you can't just put the base as the exponent. It's almost like you have to rotate it to the bottom. And the way that you do that is you rotate the base into the subscript. Now, our calculator has a way of figuring that out, and we'll talk about that in just a minute, but that's how you write it. And so in my mind, the way that I kind of think of it is as when we invert that exponential, it inverts the base into the bottom. Now not like a division problem. So it's not like into like an inversion as far as like numerator denominator inversion, but it's like a exponent superscript to a subscript. Okay, and we'll talk about that. We'll talk a little bit more about what that looks like here in just a minute in the lesson. But you need to know that. You need to know the standard form right there. Y equals log base x times x. Now, this is not an exponent x. That's just an x. So the only thing that's subscript is that right there. Everything else would be just, well, let me try to draw a straight line there. There we go. Everything else would be along that line. And then the only thing that's sub is that b. There's no exponents here. Why not? Because it's logarithmic. It's not exponential. So we don't have any exponents. We have a logarithm. Okay. All right, let's keep going with this. A couple things here that are important to know about your base, the same as the exponential, so it carries over. The base has to be greater than 0. Okay? If the base is 0 or negative, then we have a problem. The other thing is that the base cannot equal 1. Why not? Because if the base equals 1, then it just equals whatever. There's no change to the equation because 1 is the identity. So we can't have the base of 1. So there you go. Make sure that you remember those. Those are from exponential equations too, but that carries over here into the logarithmic equations. All right, turning the page over to page 341. Page 341. Let's talk about what's called the common logarithm, the common log. It is any logarithmic function with a base 10. Base 10 is what they call the common log. Now, what does that mean? That means it's the one that if you're dealing with a log problem, you are dealing with 10. Now, I wrote this down here, but it says calculators use the common log. The base 10 is understood and does not need to be written. So let's rewrite this one not using the base 10 because we don't need base 10. We don't need to write it with base 10. So we can actually get rid of that and we can just write log x, whatever x is. Let's say log 3, for example. Okay? What that means is our base is 10. If you write it with nothing there, it's like a base 10. What are some other understood things that we have? Well, we have our x. What's the coefficient of x? 1x. That's right. And what's the understood exponent here? 1. Okay. What's the understood sign for that? A positive. Right? You don't need to write positive. You don't need to write this one, and you don't need to write this one. Why? Because all of that stuff is understood. When I write x, all of that's understood. I know it has a coefficient of 1. I know that it has an exponent of 1. And I know that it's positive just by writing x because all of that's understood. So, same thing here. I know that the base is 10 if it's not written. If there's no base, the base is base 10. Super important. Common log, base 10. That is what it is written in. You need to know that. That's super important. That's something you need to put into your memory bank. Okay. So if I write it like this, that means I'm using base 10. Notice it says calculators use the common log when calculating logarithmic functions. The base 10 is understood and does not need to be written. All right, so let's look at this one right here. In other words, this is a log base 10, but we don't need to write the base 10. We just know that it's log base 10 because that's what calculators calculate in. So if I go to my calculator and if I want to put in log of 2.5. I would come here. Now, there's different ways to use your calculator. Everybody's calculator is different. Sometimes you have to put in the number first. So instead of putting in log first, you might have to put in 2.5 first. So 2.5 and then hit your log button. That's what I have to do on mine. Other calculators, maybe you have to put in log first, then 2.5. I don't know what your calculator is set up for. Everybody's calculator is different. So you figure out how yours works. Here's what you should get for an answer, however. You should get 3.979. We can always round off in Algebra 2 in this course. You can always round off to 3 decimal points. So we would round off to the 7. The 9 is bigger than a 5, so it's going to make that 7 go to an 8. So 3.98 or 0.398, sorry. 0.398 would be our answer to log of 2.5. Or log 10 of 2.5, but you don't need to write that log 10. So that's your answer. Okay, very, very simple. Just hit the log button. Some of you wondered what that log button was for. Now you're finding out. You still don't really know. you still don't really have a real good idea of what it means. Right now, you only know that it means the inverse of an exponential, and that if you hit it, you get this answer. We're going to figure out more about this. We're going to talk more about what the log is, how it works, when it works, and all that good stuff. Okay. All right, let's keep going. We are on the bottom of page 341. Bottom of page 341, we read about what's called the natural log, or the ln. The ln. Now, Maybe you're thinking, I think on my calculator, when I look at my calculator, they spelled it backwards. Okay, it should be NL, natural log. All right, well, yeah, you're right. But this comes from the Latin natural log in Latin. The words are switched, so it's LN is where that comes from. Just so you know, it's not backwards. They did it right, and they did it for the Latin of natural log. But this is what's called another often used base. I don't want to call it another commonly used base because we already have the common log here. So I don't want to use that word common. So let's use the word often used. We use this a lot. And it is based on Euler's number, or the E on your calculator. Remember the E that we were working with the other day? So the little E on your calculator is Euler's number. Natural log is based on Euler's number. Remember how I told you that Euler's number was important in exponential? Well, Euler's number then becomes important in logarithmic too, because it is just the inverse of the exponential. So if it's important in the exponential, it's important in the logarithmic. So the only difference is we don't call it Euler's number when we're dealing in the logarithmic functions. We call it the natural log. Okay. So if I want to find the ln of 4, the ln, the natural log of 4, I would come over to my calculator, go ahead and clear it out. And again, you had to find out how your calculator works. They're all different. Every manufacturer, every model is a little bit different. So what I would do on mine is I come over here and I push 4. And then I come over here to the ln button and I just hit the ln. And I come up with 1.386294, blah, blah, blah. All right, keeps going. Well, I want to round that off. What do I want to round it off to? Well, I round it off to 3 decimal spots, and so I would get 1.386. 1.386, because the next number was a 2, and so that's smaller, and so we can just get rid of the 2. Hopefully I don't need to remind you how to round off. Since you're in Algebra 2, you should already know that. Okay? All right, there it is. It's pretty self-explanatory. I mean, you just take this and you figure it out. Your calculator could be a little different than mine, but mine is I have to type in the number first, then I hit natural log, and it gives me the answer. Okay, pretty simple. The same thing is true on natural logs. The x has to be greater than 0. Okay, the x is greater than 0. Obviously, the base is from Euler's number, so it's going to be not 1, but it's got to be greater than 0 is the big thing there. And that's on page 341 as well. All right, well, go to page 342. Amazingly enough, I'm going to finish this whole lesson in one video, so that's going to be awesome. I don't think it'll be too long either, because I don't have too much more. This is called the inverse relationship on page 342, the inverse relationship. What does that mean? Well, a relationship is the way that two things interact with each other, and the inverse is the opposite. So how does the opposite function interchange with the regular function? What's their relationship together? The exponential function and the logarithmic function are inversely related. What does that mean? When one goes up, one goes down. Okay, that's what inverse means. So remember when we worked with inverse functions, if one function was going up, then there was a division happening that made the other one go down. You can recall this and how we solved inverse functions from lesson 7.1. Go back and review that if you are wondering about how we did that. Now, in 7.1, we learned something about the function, and we learned about the what we call the asymptote. The asymptote is, in this case, it's this line right here for the function. This is the exponential function, okay? In other words, that exponential comes close to reaching the x, but it never reaches the x. What's the asymptote on the log function? Remember, it's the inverse, so it's going to be the y. It comes down, it gets close to the y, but it never touches the y. Okay. So they would have different asymptotes. The log function is going to have the opposite asymptote that the exponential function has. So if the exponential, the asymptote for this one is this axis right here, the x, then that would flip it and change it for the inverse, and that would make this one the y. All right. What else? This is an interesting thing. Notice that these two things right here, they kind of look alike, right? It's like one goes one way and one goes the other way. Well, that's what's called the inverse of the two. It's almost like you're looking in a mirror, right? So again, we go back to that reflection idea that we talked about in the first lesson of this chapter. Now watch this. If I put this dotted line up through the middle of these, this line that I just created right here, and it's on page number 342, this line is called the axis of symmetry. 2M, symmetry. Okay? And the axis of symmetry means that they are what's called symmetrical. Well, what does symmetrical mean? It means that they are the same except for they go different directions. In other words, they're the same shape. They're symmetrical. Their shape is the same. But the only difference, like if you took that pink line and you folded it over, it would lay right on top of the green line. If you took the green line and folded it over, it would land right on top of the pink line. So they are symmetrical to each other, or they're the same, they're just in different directions. This line that goes between them, it's almost like an asymptote, but it's a little bit different. It's called the axis of symmetry. And we can actually, there's a way that we can find out what that is. We can find the equation, because every line has an equation, right? So we can find out the equation of this line. That's something that we will find out here in the next few chapters. But the axis of symmetry, okay? And there's a picture of that in your book as well on page 342. Last thing that I have for you in this chapter, or in this lesson, not the chapter, there's more in the chapter, but in this lesson, some of you are like, oh man, I was hoping we were done with this chapter. No, we're just getting started with this chapter. Lots more. Right here, the converting between exponential and logarithmic. How are we going to convert between them? Well, look at the screen, and I have an exponential function written here, and then I convert it to a logarithmic function here. So what does that conversion look like? Well, here's what it looks like. It looks like we switched the x and the y, and then we solve for the y. In other words, we got the y by itself. How did we do that? I'm not so worried that you know about the how we did that. I just need you to know what these two things look like. Exponentials look like that with an exponent, the base and the exponent. Okay. And logarithmic looks like this. So what is that? Well, let's look over here at the exponential since we have a little bit more experience with the exponential. What is that? Well, look here. The y is the exponent. Notice how we put the y out front. Why did we do that? Because we're solving for y. That's the plan here. That's what we're trying to do, is we're solving for y. So we put the y out front. Then what do we do? Well, we have to move the x over here. We have to multiply both sides by x. That is being multiplied by x. The base is a little bit trickier because remember how I said you have to invert it, but there's no way to invert it because we're not technically dividing. We're not going to divide by the base. Why aren't we dividing by the base? Because it's exponential. We're not multiplying by y. We're exponential by y. The exponent is y. So the way that we do that is we've created this. Mathematicians have created this little formula to say we're going to find the logarithmic function of this base, log base. Now, so you just put stuff where it goes. The only thing that we haven't really named yet is this right here, and that's the x, and we call the x the argument. I typically don't call it the power. The book uses the word power. I don't like the word power because I feel like the word power, you confuse it with an exponent because an exponent is a power. So I don't want to use the word power because I don't want you to confuse that. So you're going to hear me use the word argument instead of the word power. But sometimes the book might call it power, and if you see that, then it's talking about the argument, not the exponent. Okay? Let's do one. We'll do this, and then we'll be done with this lesson. All right, so here we go. We have 4 squared equals 16. That is our exponential function. We want to convert this thing over to a logarithmic. So what do? Well, we just write it like this. We write the exponent out front. So what's the exponent? It's the 2. So we get 2 equals. Then what do? Then we write log base. So log base. What's the base? The 4 is the base. So we're going to write that there. All right. And then what is the x? The x, and I wrote this one backwards, I guess. So yeah, technically the way that it's written here would be 16 equals 4 squared. So sorry about that. I kind of switched these around, but that's not a big deal. So the 16 is the x, and so where does the x go? The x goes here. It's a multiplier, and so that's what you would end up with right there. 2 equals log 4. That's our base. Notice that this is not the common log. We have a different log. I haven't showed you how to figure this out yet. You don't know how to solve this yet. You don't know how to make your calculator solve that. So maybe that's something that you could look into. How can I make my calculator solve that? Because I don't know. My calculator doesn't have a base with it. It just says log. So it's using the common log. So maybe you can fiddle around with your calculator and see if you can get it to give you an answer to that. So, all right, there it is. That's all I have for you today. Hope you learned something. Try some of these practice problems. Try to go in there and see if you can figure some of these out, how to move these around, how to convert it from exponential to logarithmic, and how to just look into some of these solutions and see how you do. All right, if you missed anything, make sure to slide it back there and figure out what you missed. We'll see you later. Have a good one. Bye-bye.